Welcome to the gaping chasm between data scientists and information systems. As data science has grown in importance, it has encountered the IS department with increasing frequency. Observing these encounters in some organization is like watching two vastly different galaxies collide. There are many loud explosions, furious disagreements, blinding thunderbolts, flashes, and a lot of misunderstanding. What's the source of these vastly different viewpoints? Nearly everything. The culture, education, work practices, organization expectations, attitudes, reward systems, and reputation of the two communities couldn't be more different. So in this presentation, I want to describe some examples of these profound differences that the sometimes inflexible IS department and the often swashbuckling data scientists encounter. Narrowing these differences and building mutual understanding will deliver more value for data science for organizations. So who am I? I founded Corvell Consulting over 20 years ago. We offer management consulting in an information technology context. We've executed many project management and system development projects with our clients who are typically in the upstream oil and gas industry. I write columns for IT World Canada that tend to focus on project management and systems development themes. For some years, I wrote for the Microsoft website, and I've been a CBC radio guest, and I was a member of the board of the Professional Petroleum Data Management Association. So here's the outline that I want to talk about today. First, a few introductory remarks, and then we're going to talk about application sustainability. I think the differing attitudes about the importance of sustainability are at the heart of the chasm between data scientists and information systems. Then we'll talk about the chasm topics. I want to spend most of our time here today discussing these 10 chasm topics that I believe are the most important to every software development project. And the approach to addressing these topics varies a lot between data scientists and information technologists. And then we'll wrap up with some conclusions and recommendations. I hope we can narrow the chasm between data scientists and the IS department and thereby position projects for greater success. Here are some learning objectives I want us to consider for today. Recognize that the chasm between data scientists and information systems can be a project failure factor. In many organizations, data scientists need some level of cooperation from information systems. Where that cooperation can't be achieved, frustrations and tensions run high. The dysfunctional situation can lead to project failure. Recognize project characteristics that will help you anticipate likely chasm issues. Examples are project size, data access requirements, number of data sources, technology, urgency. So then we want to understand the sources of these chasm issues, and I think they're a product of factors including prior software development, project management experience of the individuals involved, their education and their careers. And then we want to learn actions to mitigate these chasm issues in the hopes that they can be narrowed or even eliminated by introducing a little discipline and perhaps formality. So let's start by looking at sustainability. I believe divergent views about the relevance and importance of sustainability are the source of the chasm between IS and data scientists. When we determine how much sustainability we need right now or in the later, and then plan accordingly, we can narrow some of these chasm issues. So what's the importance of the sustainment, application sustainability? Perhaps not surprisingly, the IS department and data scientists have hugely divergent views on this topic. The IS department assumes everybody wants these abilities that together define sustainability in their production quality applications. Together, these abilities deliver a superior, consistent end-user experience. However, the assumption that everybody wants these abilities is not at all accurate. Data scientists, for example, don't pay much attention to these abilities. So perhaps these abilities aren't as important to success as the IS department assumes or even asserts. Even when end users and executives haven't expressed any interest in these concepts, the IS department always assumes or insists everybody really does want these abilities. The IS department knows that the moment an application outage occurs, the phones will start ringing at the IS department with everyone demanding to know why the problem hasn't already been fixed. However, many data scientists don't expect their projects will actually go into production. So the IS department is overreacting by promoting or even insisting on these abilities. So how much sustainability do we really need? Data scientists often think that the amount of attention that needs to be devoted to sustainability is none. They think that the key deliverable is an exciting list of insights. Once the insights have been explained, the associated code and data can be thrown away. Therefore, including sustainability features in the design is a waste of time and money. In my view, this logic applies only to the limited case where the project is about exploration of data to test a hypothesis. In this simple case, there's no intent to reuse the software created for further exploration or promote it for production use. I believe that the larger your audience is, or the number of stakeholders, the more likely it is that you're going to need some sustainability features. So if you're just exploring, like the diagram, the cartoon on the left, you probably don't need any. If you're really building a production application, you need lots of sustainability features. So here's my advice to you. If you don't think you need any, you can doze off or go eat a cookie. If you need some, you can listen. And if you need a modest or a lot, then please pay attention to the presentation that I'm about to discuss here with you. So as we learned from Dilbert, they have a dysfunctional approach to many subjects. I wonder how the boss wants us to handle sustainability. And Wally says, I think we should virtualize the model and move it to the cloud. Hey, that's a great idea. Sustainability is a piece of cake. Wally's baffle gab is not a good architectural choice. Sustainability is valuable, but it's not a piece of cake. So let's get into the Chasm topics. You'll notice that how we choose to address every one of these topics can contribute to or undermine sustainability of our software development work. Let's look first at Project Kickoff. The IS department starts a project with a comprehensive charter that describes the project. It's been thoroughly reviewed with the sponsor and key project stakeholders. The goal is to achieve consensus among the key stakeholders about what the project is all about, its benefits, and its estimated costs and likely risk. On the other hand, data scientists start projects with a barely legible hypothesis that's scrawled on a whiteboard accompanied by a large PLO letters in a messy workroom. The goal is to enlist creativity of the project team to prove the hypothesis. Now, here's my recommendation, and it's a recurring recommendation for every Chasm topic that we'll discuss. Determine how much or how important sustainability is to your project. The sustainability determination leads to a formality discussion. More formality in the production of deliverables leads to more sustainability. More projects fail due to insufficient formality than due to too much formality. Don't believe that informality is faster and cheaper. Running code is never the only deliverable of your project. Okay, moving on to the second Chasm item, business requirements. The IS department expects business analysts to develop a formal business requirements document that includes lots of descriptive text and diagram. The goal is to elaborate the high-level requirement statements in the charter to confirm the detail with the project sponsor. In addition to functional requirements, sustainability is represented by the abilities I listed earlier, receives lots of attention. Data scientists, on the other hand, collaborate informally to develop requirements using an online collaboration environment, lots of white space, a myriad of emails, and lots of text. The goal is to bring leading research and data science experience to bear on testing the hypothesis. Sustainability receives little attention because it's seen as an unimportant distraction. Application design. The IS department wants project teams to elaborate the many business and data requirement statements into a comprehensive set of end-user stories and then prioritize those stories for development. The goal is to fill in the inevitable gaps in the initial requirements stated in the project charter and to ensure that the most important functionality is developed first. Data scientists, on the other hand, add to the design of their model iteratively as each execution reveals problems and new opportunities to converge on the hypothesis. The goal is to remove the inevitable errors in the thinking about the hypothesis and apply the latest data science thinking to irrefutably proving or rejecting the hypothesis. Informality is fine in this situation because the goal isn't a production quality application. software development methodology. The IS department applies its accepted and sometimes overly bureaucratic software development methodology to the project characteristics. The goal is to ensure quality and sustainability in the planned solution. The IS department recognizes software development as a professional discipline that produces quality and reduces risk. Data scientists, on the other hand, view development methodologies contemptuously as straitjackets that constrain creativity at best or crutches that help dullards produce useful work at worst. The goal is to avoid a framework with this kind of structure that might constrain creativity. Data requirements. The IS department expects project teams to include data structures and data quality in the design to ensure that the planned application contributes to enterprise data management and data integrity. The goal is to avoid road applications that don't fit into the application portfolio and create sustainability problems. On the other hand, data scientists scour the organization and perhaps the planet for data with the ferociousness of V'ger consuming stars and planets in Star Trek: The Motion Picture. They create new columns and tables as their usefulness arises from the detailed analysis of existing data with no thought to data modeling best practices or data management considerations. The goal is to avoid anything that sounds or feels like structure that might interfere with identifying golden nuggets of insight. Software development. IS department, what do they want to do? They develop application software with rigorous peer reviews and comprehensive testing. The goal is to deliver software with as few defects as possible to achieve a quality production application. The IS department recognizes that viewing software development as a discipline adds to sustainability and reduces expensive rework. On the other hand, data scientists like to keep coding until they see something they like. The goal is to fail fast and often on the road to a viable and defensible solution. The risk of an appealing result that appears to be the defensible solution is in fact the result of a software defect is seen as low. Success criteria. The IS department views success as delivering functional, stable applications for routine, no-drama use by the planned end-user community. The goal includes meeting the sustainability list I showed earlier. If the project is reasonably on schedule and on budget, that's a bonus. On the other hand, the data scientists view success as discovering breakthrough actionable insights in the organization's data. Sustainability and other features such as error checking, disaster recovery, data integrity are not part of the success criteria. The goal is to minimize elapsed time to actionable insights. Because most projects are quite short, adhering to a budget is not an issue. Operational methodology. The IS department is proud of their detailed ITIL procedures that achieve high availabilities. These procedures implement the operational methodology to achieve a high availability computing environment and other sustainability components. The goal is to ensure superior customer satisfaction levels of end users of the production quality application. Data scientists never think about operational methodology. The goal is to find hidden insights that can outsmart the competition and advance the company's business plan by leaping over tall buildings. Data scientists are only building code for themselves, never others. Sustainability is not needed. Deployment. IS department plans for the deployment of new applications with careful attention to people change management issues and the cutover from the predecessor application. The goal is to minimize disruption during the deployment and transition. Data scientists don't expect to deploy their software to anyone else, so they don't think about deployment. Awareness of the idea that software should be designed to run again next week or next month without a lot of babysitting or further development is generally absent. Usually there's no goal to move the code and data into production. Project elapsed time. The IS department tries to minimize project elapsed time, but achieving scope and quality typically take precedence. The goal is always a robust, high availability, production quality application. Data scientists understand how critical first to market is and focus on the shortest possible project elapsed time. Considerations of software stability, ease of use, data quality, and sustainability take a backseat. So those were the 10 Chasm issues and some ideas on why the two groups are different. Let's talk about what we've learned from this description. We defined sustainability. I've described the major topics that are the underlying reasons for the gaping chasm between data scientists and information systems. The vast differences in goals and background between two groups is obvious. I hope the descriptions made the differences clearer and understandable. I suggest you explicitly determine how important sustainability is to your project and then recognize that conclusion in your project plan and in your project budget. So what are some conclusions we can draw from these descriptions? An appealing data science insight will result in a request for repeatability. Repeatability in turn triggers the need for some or even significant sustainability. That's the moment to start including sustainability features in your project plan and budget. Software developed and data gathered to achieve the initial insight should be seen as a prototype, not a production quality application. Emphasizing this point in your stakeholder communication is important. Otherwise, stakeholders tend to believe that your prototype is a new application that can be placed into production tomorrow morning without much more attention. So here are some recommendations that I think will help you be more successful. Think carefully about your project audience. The larger your audience is, the more likely you are building a production quality application, whether you realize it initially or not. If you can't figure it out, pitch your initial project as an R&D project with no expectation of a production quality application as a key deliverable. Second, educate your stakeholder on the difference between a prototype and a production quality application so they'll be ready when you hit them with the associated costs and project timelines. Third, plan for sustainability. When you're asked for repeatability, include the effort and schedule to incorporate sustainability in your project plan and budget. Don't disparage the principles of software engineering. Software development has evolved as a genuine professional discipline based on many painful experiences accumulated over many decades. Your project is not somehow exempt from the principles of software engineering. You can't deliver faster by claiming the principles of software engineering are slowing you down or don't apply. What are the strategies you would pursue to bridge the chasm between data science and the IS department? The first one that I would think about is scope clarification among all of the stakeholders. And the second one is to set the bar appropriately on sustainability and formality. Accept that the requirements of a production quality application are in fact legitimate. So I hope we've been able to help you identify these. Do any of you have any questions? Thank you for your participation today. And if you'd like to contact me, here is some information. I look forward to any further discussion.